All right, welcome back, class. Mr. Pusky here. We're continuing with 6.4 day 2, which is solving polynomials. And so we were working on just factoring in day 1. Now we're actually going to be solving. So the difference between just factoring and solving is when you solve, you take each part of the factored form and you set it equal to 0 and you solve it, basically, okay? So for example, if we had x plus 2 times x squared minus 4 equals 0, you would do x plus 2 equals 0, and you would do x squared minus 4 equals 0. Oops. And then you would solve those from there. So it's basically the same thing we were just doing, except we're going to be doing one extra step or by solving, okay? All right, let's get right into it. So we have 2x to the 5th plus 24x equals 14x to the 3rd for number 1. So first things first, we need to make sure it's equal to 0 to solve these kind of problems. So are these equal to 0 right now? They are not. So we need to get rid of that 14x to the 3rd and move it to the left with everything else. So I'm going to subtract 14x to the 3rd from both sides. Then I'm going to get 2x to the 5th minus 14x to the 3rd. Write it in standard form from biggest to smallest exponent. Plus 24x equals 0. All right. So the first thing on our factor flow chart next is to check for a GCF. Is there a greatest common factor we can factor out of here? There actually is. There's a, we can pull out a number that goes into 2, 14, and 24. The GCF is going to be 2. 2 is the biggest number we can pull out of them, and the smallest exponent we can pull out is an x. We can pull out an x then. So we have 2x. Now we got to write the rest of it by dividing by 2x. So we're going to have x to the 4th minus 7x squared plus 12 equals 0. Okay? So the first thing we did, I'll write it down there in a little. I'll write the steps we took in a little while here, but okay. Now we need to factor what's inside the parentheses. So how many terms do we have there? We have 3 terms. So now we need to check if we're going to be using smiley face method or perfect square trinomial, or anything like that, or a quadratic formula. So we have 3 terms. It is not a perfect square trinomial because 12 is not a perfect square. So we are going to be doing smiley face method. Okay. So we have 2x times, we need factors of x to the 4th. What are the factors of x to the 4th? Those are going to be x squared and x squared. Now we need factors of 12. We're going to do, let's do smiley face right here so we can see it all nicely. We need factors of 12 that are going to add to negative 7, and then it's positive 12, so they both have to be negative to multiply to positive and add to a negative. And what numbers add to 7 that are factors of 12? Well, we can do 4 and 3. So if we do that, we're going to get negative 4x squared, and we're going to get negative 3x squared, which equals negative 7x squared. So we know we got the right factorization here. Okay, so now we have 2x times x squared minus 4 times x squared minus 3. Now we check for the x squared minus 4 and x squared minus 3 and see if we can do any more factoring. Well, x squared minus 4 you can see is a difference of squares, or 2 perfect squares there. So we're going to write 2x, and then the factors of x squared minus 4 are going to be x and x, and 2 and 2. We're going to put plus or minus between them. And x squared minus 3 is not a difference of squares, so we're going to kind of keep that the way it is. Equals 0. Okay, that is as factored as we can go because x squared minus 3 is not anything we can do. 2 terms, it's not a difference of squares. So now what we need to do is we need to take each of these expressions here, the 2x, the x plus 2, the x minus 2, the x squared minus 3, and set them each equal to 0. That's how we solve. We're trying to find what makes each of these equal to 0. So we're going to do first 2x equals 0. So how do I solve 2x equals 0? Well, I'm going to divide by 2. I get x equals 0 divided by 2 is going to be 0. So that's one of our answers. Now I need to do x plus 2 equals 0. Well, I can just subtract 2 from both sides now to get x by itself. We get x equals negative 2. Then we have x minus 2 equals 0. We add 2 to both sides. We're going to get x equals 2. And the last one we have is x squared minus 3 equals 0. This one's a little bit trickier. So we need to add 3 to both sides. So we get x squared equals 3. Now how do I solve for x? Well, I need to take the square root of both sides. I'm going to get x equals. Now we got to be careful. We took the square root of x squared, so we need plus or minus square root of 3. So these are our final answers for this problem here. These are our final answers. These are all solutions that cross the x-axis, the x-intercept, okay? So here's our steps we took for this one. This one's kind of tricky. First step we did, we took a GCF. Second thing we did smiley face. Third thing we did was we did difference of squares. Then the last thing we did is called zero product property. Oops. And that means set equal to 0 and solve. Okay, so those are the steps we took for this problem here. Okay, we got 2 more examples there, so let's get right into it. Just take a second so you guys can write this down if you can't see everything. Okay, now we have x cubed minus 27 equals 0. First thing we always check for is for a GCF. Is there a number that goes into x to 1 and 27? No. Is there a variable we can pull out? No, 27 doesn't have a variable. How many terms do we have here? We have 2 terms, so it's either going to be a difference of squares or a sum or difference of cubes. Well, this is a difference of cubes, so it's a difference of cubes for this one. So let's go ahead and solve this here. So the cube root of x to the third is going to equal x. The cube root of 27 is going to equal 3. And so now we need to go ahead and do our difference of cubes formula. So it's going to be a minus b. So this equals a. This equals b. So a minus b is going to be x minus 3 times a squared, which is x squared, plus ab. So x times 3 is 3x. Plus b squared. Plus b squared, 3 squared is 9. And we set that equal to 0. I should have asked first before we started solving, is it equal to 0? Because that's most important, and it is equal to 0. Okay, so we can solve the first part, which is x minus 3 equals 0. We can add 3 to both sides. X equals 3 is one of our solutions. And then for this one, we try to factor it. So we can do smiley face method. We can do, it's not perfect. Well, first square trinomial would almost work, except it needs to be double 3 times x, which would be 6x in the middle. So it's not a perfect square trinomial. It's not smiley face. We can't find factors of 9 that are going to add to 3. So our last resort, when we can't factor something using traditional methods, is we need to use quadratic formula. So I'm going to draw this over here. This one's going to be, we're going to do quadratic formula. You can use quadratic formula every time, basically, for a something like this, but for a quadratic expression that doesn't factor, or does factor, it'll still work either way. We need to find our a, b, and c. What's our a, b, and c? Well, in front of x squared is 1, in front of bx equals 3, and in front of the c value is going to be 9. So we're going to plug into the quadratic formula, which is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So let's plug it in now. Here we go. X equals, opposite of b is negative 3 plus or minus square root of, let's fix that square root, b squared, which is 3 squared in parentheses, minus 4 times a, which is 1, times c, which is 9, all over 2 times a, which is 1. Okay, now we're going to get x equals negative 3 plus or minus the square root of, it's going to be 9 minus 36 all over 2. And we get x equals negative 3 plus or minus square root of negative 27 all over 2. Well, the discriminant is negative, so what kind of solutions are we going to have here? This means, let's draw a better arrow. This means we're going to have 2 imaginary solutions. So we have 1 real solution, which is x equals 3, and 2 imaginary solutions. And that's all it wanted us to find for these problems, was to find the real solutions, the real number solutions. So x equals 3 is going to be our only answer for this one, basically. And our steps for this one, we did first, we did difference of cubes. And step 2, what we did was we did quadratic formula. And those were our steps. All right, last example for today. We have x cubed plus 2x squared minus x equals 2. First things first, in order to solve polynomials, we need it equal to 0. Is it equal to 0 right now? It is not. We need to get rid of that 2. How do we get rid of that 2? We subtract 2 from both sides. 2 is not a like term with anything else. We're going to rewrite this as x to the third plus 2x squared minus x minus 2 equals 0. Is there a GCF we can pull out of all of these? Well, it's a 1x, so that we can't pull out any GCF for all of these altogether. There's no number, there's no exponent we can pull out. 2 doesn't have an exponent. 1x is not, you can't pull out a 1, that's not going to do anything. How many terms do we have here? We have 4 terms. So we are probably going to do grouping. So let's go ahead and do grouping. So we're going to go ahead, we're going to split it here. Check our signs. These are both positive. These are both negative, row, so we're going to need to pull out a negative when we do this. What's the GCF out of x cubed and 2x squared? That's going to be x squared times, and then we're going to have x plus 2 when we factor that out. We do not like the sign, so we're going to pull out a negative here instead of a positive. And what can we pull out of x and 2? We can't pull out anything, but when you can't pull out anything, you're going to pull out a 1. So we're going to do minus 1 times x plus 2. Do you see why we did that? When we did that, we pulled out a negative one. It became instead of negative x minus 2, it became x plus 2, and then we wanted these both to match. Because if you pull out a positive, if you pull out a positive one, you're still going to get negative x minus 2, which means they don't match up. So that's what the negative does right here when you pull out a negative. So that's why we do that. All right, let's pull out our GCF. We have x plus 2 times x squared minus 1 equals 0. So now it's factored. Now we got to check inside the parentheses. Can we factor x plus 2? No, we cannot factor x plus 2. Can we factor x squared minus 1? Well, it's 2 terms, and those are both perfect squares. 1 is a perfect square. So we can factor this into x plus 2. And then the difference of squares, so we're going to have square root of x squared is x. Square root of 1 is 1. We have plus or minus here. And now, zero product property, we need to set each part equal to 0. So we're going to have x plus 2 equals 0, x plus 1 equals 0, and x minus 1 equals 0. That's just we can just do the shortcut here. We don't need to write it out. X equals negative 2. X equals negative 1. And x equals 1. And these are our answers. And our 2 steps, we did grouping. And we also did difference of squares. And those were our steps. All right, thank you for watching. Have a great day. We will talk soon.